Verify worksheet number 1. This is going to be number 8. I thought this one was probably the most difficult one on the page. It's nothing crazy hard about the substitutions. It just takes a bit of time and a little bit of creativity to figure this one out. Okay. Number one thing is don't get frustrated by simply looking at the equation. Take it a piece at a time. Okay, the first thing you notice, you have sine squared x times cosine squared x over sine squared x minus 1, all of that plus tangent squared x equals tan squared x times sine squared x. So it's 2 parts equal to 1 part, because the plus sign separates your pieces. So you have 1 fraction plus tangent squared, and then over here we just have one term. It's tangent squared times sine squared. So the first thing I think about is, well, I need to somehow get these 2 pieces into one piece like this. The first thing I look at when I'm thinking about substitution is I see a sine squared x minus 1. If you've watched the other videos in this series, then you remember that we did this earlier for one of the simplifies. Normally we see 1 minus sine squared. Here's it's backwards. The signs are backwards. And so when it's equal, and I've done the work for you over here if you quite haven't figured it out yet. But we're going to make a Pythagorean identity substitution. Okay. I do this because I see a cosine here, and I'm thinking maybe I can get that just to straight up cancel out, and maybe that'll kill my fraction, and I'll be able to work without a fraction. So the first thing we're going to do, and I'm going to show you the conversion if you haven't seen this already. I start off with sine squared x plus cosine squared x equals 1. I'm going to subtract cosine from both sides of my equation, and I'll end up with this. Sine squared x equals 1 minus cosine squared x, because the cosines cancel out here, and so I'm left with this part. Not quite there yet. I actually want to get the 1 on the other side, so I'm going to subtract 1 next. So subtract 1 from both sides, and this is what we end up with. I get sine squared x minus 1, which is what I wanted. That's equal to negative cosine squared x. So I'm going to take the negative cosine squared x, and I'm going to substitute that in for my sine squared x minus 1. Okay, so we have this substitution, sine squared x times cosine squared x, all over, here's the change, negative cosine squared x plus tangent squared x equals our tangent squared x times sine squared x. And so once I see this happen, I see that it cancels, but be careful. That's not just a straight cancellation. We have a negative sign in play. Okay, that negative sign is still going to be there. So when you cancel the cosines out, sure, the cosines are gone, but that's still a negative 1. So what that's going to make that sine squared is become a negative sine squared. If you leave that out, then this wouldn't work. Bring my tangent squared down. No big change there, but I can see where a lot of you would simply forget this or think it's canceled out with the cosine. Don't forget that. That just changes the sign of sine squared. Okay, when you have this part, here again we're going to try to change things into sine and cosine. So I'm going to take my tangent squared x, and I'm going to change that into sine squared x over cosine squared x. This is the part where you have to really think about it. Sometimes you don't see that these 2 things have a common factor because one of them is a fraction and one of them is not. I originally did this a different way, and I got stuck, and it didn't work out, or it would have been more complicated than I wanted it to be. And so I went back. I went back to this step up top where you have the negative sine squared x plus tangent squared x. And I thought, well, what else could I do? Originally, I tried to find a common denominator or something. I'm not sure exactly what it was, but it didn't work out very well. And so I went back and I looked at this. Well, what else could I do? Well, this is like sine squared x, negative sine squared x over 1. I can factor out a sine squared x from both sides, or from both parts. So that's what I did. I factored that out, and I said, well, what would that leave me with? And I knew there was a negative 1 in there. And I just pulled it out, and you can see where the sign comes out, and you're left with negative 1 here. the sine squared x comes off the top, leaving you with a positive one because it's a positive here. And when I look at this, I'm thinking, okay, well, sine squared, okay, that's cool because my original solution has a sine squared in it. So I'm hoping that next part changes the tangent squared, and if it does, we're good. So I look at that and I'm thinking, that's secant squared, and that's a -1. If I check my Pythagorean identities, I'm pretty sure it turns into this. Okay, putting the -1 at the end and putting my secant squared x at the front, I get sine squared x times secant squared x minus 1. And to finish it off, we substitute that for tangent by using my Pythagorean identity. This would be the reciprocal identity to go to secant squared. Pythagorean identity comes in here, and then I rearrange it a little bit, just putting the tangent first because that's the way it is in the other problem on the other side. And you get a tangent squared x times sine squared x on both sides of your equation, and that finishes it up. Now this one, I would put this one up there as one of the more difficult ones, not necessarily a long one, but this little factoring here is the key. If you can't remember to factor that, or you didn't see that to start with, then you might not have gotten to the answer of this particular method. Okay, if you have questions about any of the ones that you've seen for this section, or I guess the second round of these videos, please go back and watch them, and rewatch them, and try to pay attention to the methods that were used. If you have any questions, please feel free to email me anytime, and I'll get back to you as soon as I can. Thank you. See you guys next week.